All right, let's go on with this last page and finish up this review. Number 22, write the inverse, converse, contrapositive, and biconditional of the following statement. The statement is, if I study, then I will pass the test. So we have here, I study. That's what we call the hypothesis. All right. I will pass the test. After then, that is your conclusion. So each of these inverse, converse, contrapositive will change the order and do some different things to them. So let's see if we can get some text writing in here. So inverse, first off, is a negation. All right, you keep the same order of hypothesis first, conclusion second, but it becomes negative. So you will see something like, if I do not study, then I will not pass the test. Okay, so negation there, the key being not study, not pass the test. All right. Converse. Converse is a flip. It's literally you just switch the hypothesis and conclusion here. So if I will pass the test, then I studied. And of course, remember, you can rewrite the sentence slightly to make it make grammatical sense, but don't change the meaning or anything like that. So again, you'll notice that now I will pass the test is in the front where it was originally the conclusion. I study, or now I studied, at the back as the what used to be the hypothesis. Contrapositive, that is both. We're going to flip them and we are going to change the order. So we're going to get, if I will not pass the test, then I do not study. All right. So notice again, it's I will pass the test. The original conclusion is now in the front and negative, right? Not. I do not study. Now the conclusion. Okay. Biconditional, not an if-then statement in general. So what you're going to do is you're going to take the hypothesis, then write if and only if, and then the conclusion part. So it should literally look like, I study if and only if I will pass the test. Okay? Biconditional does not have any if-then part of it other than the if and only if part. Okay? So it's hypothesis, if and only if, conclusion. All right. 22, if ray, okay, this is ray, AB is the angle bisector of DAC, and BAC is 52 degrees, what is the measure of DAC? Of course, if this all confuses you, draw yourself a picture. All right, so you have DAC, so D, that's a B, A, C, right? Put a point there. And BAC is 52 because AB is a angle bisector. So you'll come out here, there'll be an actual B there, right? That's D. Now a bisector, angle bisector, is going to cut this in half. So this angle and this angle will equal the same value. Now if BAC is 52 degrees, they want to know what DAC is, the whole thing. Now obviously if this is an angle bisector, we said those angles inside are the same, so this is also 52, and then it's simply 52 and 52, can't write, 104, 104 degrees. Okay? Are the following triangles similar? Justify your answer. So remember what our three similarity shortcuts are, different from congruence, right? We have side, 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 angle, angle, and side, angle, side. Now, looking at what they gave us, they only gave us the side lengths of each triangle. So we can't do anything involving angles because we don't know the measurements. So if it's going to be similar, it's going to be SSS. But there is a possibility it's not. What you're going to have to do is see that all the ratios match up. Now, what you want to do in something like this is take the smallest side here, 18, smallest side here. Those are corresponding sides. They're the smallest of their triangle. You go 18 over 24, reduce. On your calculator, if you just divide 18 by 24, it'll give you an answer of the reduced fraction. But what is this going to be? 6, so 3, yeah, 3/4, right? Divided by 6. Okay? And then you're going to take the middle length, 21, 28. Same thing. That will divide by 7. 3/4. Take the largest two. 33 over 44. Divide by 11. 3/4. These are all the same. That means they're in proportion. The ratios match up every time. So this is in fact similar by SSS. 24, again, are the following triangles similar? Justify your answer. So let's again remember what our three possibilities are: SSS, SAS, AA. Definitely no side lengths given here. Nothing to say that there's some of the midpoint involved. All we have are vertical angles here and these parallel lines. So not going to do SSS or SAS. If it's going to work, it's going to be AA. But again, it could be no. They could not be similar. But the parallel lines here, remember, as we've talked about so often before, generally the reason they give you parallel lines is to have parallel lines cut by a transversal. And this angle here are going to be alternate interior angles. Okay? So it's not always alternate interior, but about 95% of the time. And those angles are going to be congruent. So there's one pair of angles that match. Right? I'll kind of redraw this to make it look a little neater. So this angle and this angle are congruent. And then here at Y, you have vertical angles, and you're going to get those two to be congruent. Well, you only need two angles to match because you know the third one has to, because they have to equal 180. So also, yes, similar by AA. So the key to the similarity problems, look at what you have available to you. You only have three possibilities. If they're not giving you side lengths or not giving you angles, that limits what you can do or what you can answer. 25, find the value of x. I know we just finished doing some right triangle and geometric mean things, but don't get thrown off. This is a right triangle. You have three sides. Okay, there's no altitude drawn, so this is not geometric mean. This is Pythagorean theorem. Right? That's A, that's B, that's C. Generally, the hardest thing they're going to do with Pythagorean theorem for you is give you C and make you find A or B, which just involves subtraction. So you have 10 squared plus x squared or b squared, whatever you want to call the variable, equals 20 squared. Okay, 10 squared is 100. 20 squared is 400. Subtract it over, x squared equals 300 square root. Now, it all depends on the semester exam whether it's going to be multiple, it is multiple choice, whether it's going to be decimal or reduced in radicals, simplest form. But we'll go ahead and do that. 300 breaks up into 100 times this 3, right? So 100 square roots to 10, square root of 3 is going to stay there because it's going to give you a decimal, and that would be your answer. Otherwise, if there was decimal rounded off as an answer choice, do it in the calculator. Probably about 17 point something, something around there. All right, so 26 is a word problem, and it's not telling you precisely how to solve it. It says, how tall is the building in the picture? So you need this length right here. If you look at the big right triangle here, it's the hypotenuse. This is a 90-degree angle here. This would be the small side, the B side, and then that's a hypotenuse. Now, what do you have in the middle that we didn't have in problem 25? You have this median. This is a geometric mean problem. Okay? You can call that A, you can call that B. This is the geometric mean. Now, just because it's not a variable doesn't matter. If it's the geometric mean, 10, you're going to set up a proportion, and that 10 is going to be diagonal, one on top, one on the bottom of the other. The other two values are made up of the two parts of that hypotenuse, because the altitude is the geometric mean between the two pieces. So you can put a 5 there, you can put B or X, whatever you want there. Right? So when you cross multiply, you get 5B equals 100 divided by 5, B equals 20. Now, always make sure, like we've talked about so many times before, that you're answering the question. 20 is not the answer. The question is, how tall is the building? You have this 20, which takes the length from the top to where D is, but then you have this 5 feet here. So 20 and 5, the building is actually 25 feet tall. Okay? But that's just geometric mean. Don't let it throw you off, because that's not a variable. The geometric mean goes diagonal from itself in the proportion. All right, almost at the end here. A landowner wants to find the distance D across the pond. Two overlapping right triangles shown below are similar. Use the measurement. What is the value of D? This is actually on our test, the similarity test. And where a lot of you made a mistake is y'all just went straight to D over 60 equals 24 over 40. This to this, this to this. And that is incorrect. Okay? You can only do that when you have values here and here that are across from each other. Okay? What you have here is a small triangle inside of a bigger triangle. All right? So what you're going to do is you're going to compare this little triangle with the big one. So if we're going to make some sort of proportion, which is how you solve it, you're going to get something like D over 60. That part's fine. But now, what is the side of the big triangle? It's not just 24, 40. It's those two values combined. It's 64. 60 from the small triangle matches with 40. So you're going to get 40D equals 64 times 60, which is 3,840, divide by 40, and you get 96. Which, if you look, makes a lot more sense than, I think it was 48 or whatever the first value a lot of y'all got on the previous worksheet, which was smaller than 60. So, small triangle, big triangle. If you need to draw them out next to each other to see them, that might not be a bad idea. Last problem, which of the following triangles are not congruent? So one more time, we have SSS, SAS, ASA, AAS, and HL, because this is congruence, not similarity. Here at A, you have angle matching, and they share a side. That's AAS. That's okay. Although not an answer we're looking for, because we want not congruent. B, you see the parallel lines on both sides. It's a parallelogram. Let's just go ahead whenever we see that picture and realize that you have congruent triangles. Right? Because this pair is going to make those alternate interior angles congruent. And these are going to make that pair congruent. And then they share the middle, so you can easily get ASA. Alright, so congruent, but not an answer for the problem. If you look over here, you have them matching a right angle They share these vertical angles, or the vertical angles are congruent, so there's an A. And then side, I don't know why it has two dashes, but that's AAS. So congruent, but not what we're looking for. Here you have vertical angles A, but if you remember for congruence, that is not one of the 5 that we have here. So this is the answer for the problem, not congruent, because AAA does not show congruence. Hope these videos help. We're going to go over these in class on Monday, and those of you testing on Tuesday, you'll get that started. The rest of you will continue some more review for your Thursday, Friday half-day tests. All right, enjoy the videos. Bye-bye.